Here we are in section 4-1, exercises 25 through 27. In this case, it says turn the repeating decimals into fractions. This is one of the neatest little connections we have from systems of equations back to arithmetic. Certainly we could turn fractions into decimals, but going back is kind of weird. And we use systems of equations to do that. So we're going to look right here. The number we want is x is 0.555. I'm going to have 3 of them written out there just for illustration purposes. Now, if we times by 10, we'll get past the repeating pattern. So if we take 10x, that's going to be 5.555, and it goes on forever just like this one does. They have the same number of 5s down there. So we note that we times by -1 and add, and what happens? 10x minus x is 9x. When you subtract over here, those cancel with all the pattern completely, and we are left with just a whole number. Fascinating. Multiplying it and using the addition property that we used with systems of equations for elimination is amazing. We actually eliminated all of the repeating pattern. Now we can solve it, and x equals 5/9. Amazing. Okay, let's look at it over here. 5 divided by 9, the fraction 5/9. Indeed, it's 5555555, and that 6 is due to the calculator rounding up on the last value. All right, number 26. Let's try that one. So again, let's write out the number that we actually want is 0.888. We'll use 3 of them for illustration purposes. Times by 10 to get past the repeating pattern, and we get 8.888. Notice we just moved the decimal one place, and we still have that repeating pattern going out forever. Subtract them, and we get 9x equals gone. 8.888 minus 0.8888 is 8. X equals 8/9. And if we use our calculator again, we can check that. 8/9 would be 0.8888888 forever, and the calculator, since it keeps going on with 8s, will round up. Excellent. Okay, number 27. Let's try this puppy. Number 27, there is something different here. Notice the repeating pattern is 0.63. So if we write this out, this is 0.636363, and it's the 6 and the 3 repeating alternately like that as the pattern. So when we multiply, in order to get past the first set of the pattern, we have to multiply by 100. So that is 63.636363, and it goes on forever. Now when we subtract them, we get 99x equals, subtract, and then everything behind the decimal place now goes away, and we get 63. Another whole number, so we can just divide by 99. We get x equals 63 over 99. This guy, it looks like it simplifies. We can divide by 9 on top and bottom, and we get 7/11. There's our fraction. We can even check that guy out. 7 divided by 11, 0.63636363636. The calculator has a 6 way out here, so it rounded that last 3 that it could display up to a 4. Excellent.